ACT 2017-18 Math Test, questions 56 through 60. Question 56. We're looking at the square below that is divided into 3 rows of equal area. So every row has the same area. In the top row, the region labeled A has the same area as the region labeled B, so they're equal. In the middle row, the regions have equal areas, and in the bottom row, the regions have equal areas. So here's the best way to do it. You can either use algebra or you can pick a number. So we have 2, 3, and 4. I'm going to pick a number that you can divide equally in 2 parts, 3 parts, or 4 parts. So I'm going to start with, most likely I'll use 12 here. So I'm going to have 12 as the length and 12 as the width. Because it's a square, everything is going to be equal. And now I'm going to look for the area of each of the A portions. So for this first portion, we can see here that these square is divided into 3 equal rows. So I'm going to divide 12 by 3 to get the value for each row. So you have a 4 here, a 4 here, and a 4 here. And then the length right here, or the width right here, is going to be 6 in this case right here, and then 4 in this case, and then we have 3 in this case. So let's look for the area of the area of A. Let's call this A1, A2, A3. The area of A1 is going to be equal to 12. Actually, that's going to be 6. It's going to be 6. 6 times 4, which is 24. Let's look at the area of A2. Area of A2 is 4 times 4, which is 16. And the area of A3 is going to be 4 times 3, which is 12. So let's look at sum of all A's. Is going to be 24 plus 16 plus 12, and that should give you 52 units. Now, area of the total square, area of square is 12 times 12, which is going to give us 144. Now we want to find out what fraction of the square's area is in the region labeled A. So let's look at the fraction here. It's going to be area of A divided by area of square. So we plug in our numbers. We have 52 divided by 144. We're going to divide this by 4 each time, so that's 13 over 36. The other way to have done this is to use algebra, but while you're in your test, it's better to just find the fastest, easiest way to do it, that is less prone to errors. So in this case, we're going to use option K. It's going to be our answer. In the second question here, 57, we have the functions y equal to sine x and y equal to sine x plus a plus b for constants a and b. So we're starting with sine x, and this is most likely a transformed equation here. The graph is in the standard xy coordinate plane. The functions have the same maximum value. So there you already have a hint on what b is going to be. Because the functions have the same maximum value, that means that we have these right here are exactly the same. So we can automatically say that b equal to 0. It means that nothing changes in terms of its his vertical transformation stays the same, so b is equal to 0. So if you're in your test, through the question you find b is equal to 0, look in your answers, you can see that there's no other option that has b equal to 0 than option A. In my opinion, you can stop here, but if you want to just for due diligence, let's keep going. One of the following statements about the values of A and B is true. Which statement is it? So we read the statement here that says both functions have the same maximum value, which tells us that b equal to 0. If you're in a test, the best thing to do once you get to that point, because you can only see that one option satisfies your answer, you can move to the next question. If you want to verify the other part of the question, you can do that, but my suggestion is that you can only see that only one answer has b equal to 0, so we'll move on to the next question. Number 58, which of the following number line graphs shows the solution to the inequality x minus 5 absolute less than equal to minus 1? So what we're going to do is we're going to get rid of the absolute value. So we're going to have 1 less than x minus 5 less than negative 1. So what you want to do here is try to solve this inequality and see which of the following line graphs has the solution set. So I'm going to add 5 to all sides. So we have 6 less than x less than 4. So what we're told here is that we're looking for a number such that x is less than 4 and x is greater than 6. Do we have such a number? So let's test some points. So x is less than 4. Let's look at 2. So 2 minus 5 is less than negative 1. So you're going to get 3 here, less than negative 1. This is inaccurate. Let's try 7. 7 minus 5 less than negative 1. So 2 less than negative 1, inaccurate. So what this tells us is once we put these test points, we can see that we have an empty set. So that means that there's actually no number in the solution set that satisfies this inequality. Number 59. As part of a probability experiment, Elliot is to answer 4 multiple choice questions. So we have 4 multiple choice questions. Let me just say question 1, 2, 3, and 4. For each question, there are 3 possible answers. So let's call that A, B, C, A, B, C, A, B, C, and A. If Elliot randomly and independently answers each question, what is the probability that he will answer the 4 questions correctly? So we're looking at random selection here, and we're looking at independent events. So what that means is that we're going to look for the probability of answering each of the questions correctly, and usually probability is, let's say probability, let's call that C. Probability of a correct answer is going to be possible answers. So it's going to be possible answers. So there's only one correct answer divided by total number of choices, which is 1/3. So in each case, we have 1/3 as the probability of selecting the right answer. Now we want to talk about independent, because the events are independent, you have to actually multiply the probability of all the events together. So the probability of correct answers in all four is going to be equal to 1 over 3 multiplied by 1 over 3 multiplied by 1 over 3 multiplied by 1 over 3. So that's going to give us 1 over 81. So the probability of making sure that he has the correct answers for all four questions is 1 over 81. That's option E. Final question in the test. The sides of an acute triangle measure 14 centimeters, 18 centimeters, and 20 centimeters. Which of the following equations, when solved for angle theta, gives the measure of the smallest angle of the triangle? So the first thing we're going to do is to put a triangle together. So this is our triangle. So let's give some measurements on the sides. The longest side we can assume is this one here, is 20 centimeters. We have a 14 centimeter side here, and we have 18 centimeters on this side. Now, what are we trying to do? We're trying to find the value of this angle that is unknown, which is the smallest angle. So usually the smallest angle is the angle opposite the smallest side. So let's look for the smallest side. So this is the smallest side, 14 right here. So this is going to be the angle we're looking for. So generally this is the cosine rule, because you have three sides and an unknown angle. So we have three sides. In the cosine rule, we can see that we have three sides and an unknown angle. Now the reason why we don't use this rule here, which is on the left hand side, this is your sine rule. For you to use the sine rule, you at least have to know the value of one of the angles. In this case, we don't even know the value of any of the angles. So we're looking for the unknown angle. So we're going to use the cosine rule. So this is cosine C. So that means we're going to start with the side that is opposite the angle. So we're going to say 14 squared, which is our C here, because it's the side opposite the unknown angle. 14 squared is equal to 20 squared plus 18 squared minus 2 times 20 times 18 cosine theta. So when you're dealing with the test, because the scope of the test isn't for you to actually solve solve triangles using the cosine rule, most times this is about where they stop. So let's see if there's an answer that matches what we've done so far. So 14 squared is 18 squared plus 20 squared minus 2 times 18 times 20 cosine theta. So that is going to give us option J.